So let's talk about Fabric real-time processing. In one of the previous sessions, session 5, we actually talk about one of the three V's of big data is velocity. Data are coming at unprecedented unprecedented pace. So it's like really coming fast and in big volumes. Also, and the requirement for processing them is also increasingly. So traditionally, what we do is to write batch loading, where data comes in from the application every day, and on the analytics side, we'll wait until the day finishes and then move the data into the analytical data platform, right? So this is a periodical loading, once per day, usually in bulk, and the latency is high, right? Because if you have data the loading, um, taking it is an 8 hours working day, starting at 8 o'clock in the morning. Usually you start like the 20 at 7 p.m. Start loading. So there will be hours and hours of loading, the delay, if not days. The reporting, this data is suitable for reporting for the historical analysis. When you analyze a 5-year trend, then probably 1 or 2 days doesn't matter. When you do a reporting of previous days sales, then the 2 hours of delay, 16 hours delay may not be important. Then it only can help so much in that it's much simpler, and it also requires like a less intensive resource usage. This is basically the fundamental reason for the people turn to batch. Because if you think about the source data comes in real time. The sales data, right? The insurance processing data, it comes in day in day out, every minute. You can't say like I have a 5 hour window. At this time, everybody comes in and buy within 1 second, then wait for another hour or 3 hours when someone else, another batch comes in and buy. Things doesn't happen like that. But if you really want to process those real time at the right time, at the time it happens, it will be very complex and costly. You will have some systems waiting there and be ready to scale up and scale down. Whereas the bulk loading usually is much simpler and less the resource intensive, and because of that, they can also handle large, slow growing data sets. Right, the cost is much lower. Now, but as we proceed to the new phase of big data, there is a requirement for real-time analytics. Like we put here use case for fraud detection. You really want that to be as soon as possible, right? Some kind of personalization, the recommendations. After you buy a product, I want to immediately recommend another product to you, right? Let's say once you buy a sock, you maybe want to buy a shoe, something like this, or once you buy a shoe, you want to buy a sock, the other way around. So this monitoring, fraud detection, real-time personalization really is a driving force of utilizing real-time analytics. That's when data comes in, immediately put that into the analytics data pool, the data platform, and with a very low latency, seconds or minutes, and start doing the data processing and analytics workflow immediately. That's the real-time analytics. Microsoft Fabric provides you with a real-time intelligence pipeline. So this pipeline starts from the data source, right? Data source, of course, you can have a SQL, you can have a database, you can have so you can have a SQL database, Cosmos DB, everything, and the streaming sources, much more. But each of this is considered as a what we call event stream. Event stream is a resource that represent a real world data source. So, for example, if it's like in Internet of Things, you have data coming from a sensor continuously, then that's an event stream. If you have a sales database that's you have a sales system, an e-commerce system that's generating orders every minute or every second, then that's an event stream. That's connected to an event stream. This event stream object will be connected to a outside source, real-time source. and it will keep on generating data regarding that event source from that event source, and form a stream of its own. And this stream of data can be served to reflex, which is an action item that will act upon the data arriving. That if the temperature is too high, start the air conditioning. If the temperature too low, start the heating unit. This is the action part, the reflex. It's also another pipeline, which is to store the event stream data into an event house. Event house is like a lake house or data warehouse where it will store data, just that it's real-time oriented. And there is something called KQL, which is a real-time query language, um, different from SQL, but you can see you can see the impact here. Something called the query language, right? So KQL is a query language used to query real-time data. You can use this query set to run against the event house to get the data snapshot, or you can directly create the real-time dashboard to display what is happening in the streamline. And finally, all these data can be inputted to Power BI for further display. And all this sit on top of one lake. One lake is where your event house sits at. And all this is called a real-time hub, where you have all the data available, where you have all the features available for your real-time analytics. So let's start from the Fabric user interface. So this is the Fabric user interface, and as you can see, starting from get data, um, you see this event stream. Event stream is where you get data, right? Once you get data, how about store? You can store the event data, stream data into event house. And on top of event house, you can do data preparation, where in which event stream can actually do some processing before it saves the data into event house. But then you have the analytical part, the data checking side, where you have a reflex, you have a activator reflex, from which it can respond to events happening. And finally, you do a dashboard. You can do the real-time dashboard or a regular Power BI dashboard to display what information is coming from the KQL. So let's start coming from the event stream. So let's start from event stream. We can start creating one event stream. Let's call it test event stream. Now, of course, if you want to have event stream, it has to have a data source, right? Usually, it will be in real world. It will be external source, like IoT device, that your iWatch, your Apple Watch, or your cell phone, or something like the e-commerce system. Or you can use sample data or custom endpoint. Let's use a sample data from Microsoft. So I'm going to use, there are three sample data for now. For example, bicycle, yellow taxi. I'm just going to choose yellow taxi. And I'm going to call taxi stream. But in reality, let me cancel that. In reality, in real world, what's going to happen is once you click on this use external source, it will connect you to a data source that is capable of generating streaming data. For example, Azure Event Hub, Azure IoT Hub, One Lake event, or you can even come up with more things like Kafka or Flink or Amazon. How about, let's see, Kinesis. Amazon Kinesis, which is AWS data stream example, right? Or Kafka, probably the most popular. Apache Kafka or Amazon Kafka, either it's or Confluent Kafka. Basically, it's the most popular stream source for now. But let's start using sample data. Taxi stream. yellow taxi. I'm adding this, and this is the stream is coming. And it's going to be keep on feeding our data. And here is a test event. Now, why this test, why this event stream is important? Because it's receiving this stream outside data, and this is where the data officially enters Fabric. This is where you can start doing processing. And here is a transform. Remember we said the event stream can receive the data and doing some processing before we save it, right? So here you can see there are two options. You can either transform them or you can add destination. Now this taxi data is a sample data from Microsoft. It's already very conforming. It's very clean and have all the data properly defined. So you probably don't need to doing some transformation. But if you want to do anything, you can filter, you can group by join, and manage fields such like making some modifications, right, and aggregate into small tables, other aggregated tables, right? Let me move this up a little bit so that you can see the entirety. Then, so this is the operations you can say. For example, manage field. You can add what you can add field like creating built-in functions, string functions, mathematical functions. You can do the ABS, you can do ceiling, exponential flooring, and and the most popular functions, of course, is the datetime function and the built-in function. Right, you can get the system timestamp, the current time, add this to the manage field, and there's an error. I think the error is because um, I haven't saved it to a place where you have a lake house. You can save it to an existing lake house. Once I added a save lake house, right? You can choose a lake house. You can choose a name, a workspace, and choose one of the lake houses. And then you can define a delta table. You can either create a new table or you can define a delta table. And finally define the data format. So as you can see, if I get it smaller and move it around, this is the outside definition, and this is the where data comes in as entry point as a text event stream. Within this text event stream, then you can do the manage field. You can save it to a lakehouse. Now we are not going to use lakehouse. Instead, we are going to use a event house, and later on we'll also show an activator. But or you can use this stream as the input of another stream, dumping the data, because this one itself is a stream. Data keep on coming in and got generated, right? You can dump this to another stream. This is also possible, but that will be make it a really complex system. In a real world system, this probably makes sense. But in our system, in our example, it's just another stream. So we are going to skip this, and we're going to skip lake house. We're going to focus on event house first. So let me see if I can. And there are certain things that you can modify for this, and you can add source, add more source, the same three sources we see before, and you can add more transformation and add more destination. You can add two the destinations here. For example, if I want to do another one, another event house, I can add this as an event house, right? So this is the test event now. Okay, now let me go to, I think I can, I think I need to publish it. Get into this test stream. Oops, what did I do? Looks like whatever I did, I lost it. But that's fine because I'm going to start with the event house anyway. Let's create an event house to store the data. So I'm clicking on this event house from the store data the tab. So we get this store event house. Let's call it test event house. Event house is a storage place, right? But of course, with storage, it comes management. That's one where you see that there is a. I'm not going to get started. I don't need that. That's why when you see this, you of course you have the overview, you have a monitoring, you can have the storage, how many size, what's the size of it, and by default it comes with a KQL database, which will store which is capable of storing your event data. Then there's the storage resources you have, the most queried database, and of course it's running 1 minute already. And the activity, what did I do? um, Databases, we have KQL databases, we have one databases, and we have this system overview. Now database is KQL database is eventually where you will store this event data. So inside the event house, you have multiple databases, and you can direct, once you connect this to a stream, the stream will dump the data into a database table that you selected. So now if I click on that database and I want to create a table inside here, there is a query set, but how about I want to create get data, right? It can be from a sample for one time, a local file, or etc., or it can come from a event stream. Existing event or new event, then it can also come directly from events data sources like a pipeline or a real-time hub or event hub or Amazon S3. So how about I get into existing event stream? I believe I created just now. Just make sure it got saved. Okay, so it was not saved. What I did just now got lost, but I can definitely start creating one. This is what I'm doing. I'm going to select the destination. This is the KQL table, and I'm going to create a table called taxi. Workspace, this workspace. Okay, so I did created that one, and it didn't got lost. But then this is the event house taxi. This is the database connection name. Next. So it's waiting for the data and will pause for a while until it get picked up. So looks like my previous definition didn't got saved properly. I have to create. So I'm going to cancel and create a new event stream. Yes, cancel. And I'm going to click on get data, get it to a new event stream. This event stream will called test event stream 2. Create. And this test event stream, I'm still going to use the same sample data. It's taking a while to load. The same sample, and the source name will be taxi stream. Add. And this time I'm not going to transform. I don't think there's a need to transform, but I go to event house. And I'm going to choose this event house. You can either doing some processing here, or you can doing a direct dump. If you do a direct event data processing, then these are the things where you see just now with all the actions you had. So I do a direct ingest. Taxi workspace event house. We already created that one, and we have this. And I'm going to save it. So now we have this. I'm going to publish, and you can also create a new processing which will change the definition somehow. But let me publish this. So the event stream, I'm closing this. Event stream 2 is properly published. Now let's go back to event house. This event house now have this query set, and I'm going to just run this. This is the KQL, by the way. I think I need to refresh this. This is again, we talked about this before. There's an issue with the Fabric and the Azure in general. How to refresh. So here I'm going to query data. Oh, not. I don't know why I could make this mistake, but you can have the taxi. It's called taxi, I believe. I need to. So it looks like I have to link to the existing stream again, which I will call a taxi. From this workspace, from the text event 2, and now we click on next. Hopefully this time it will provide the data much faster. Okay, so far there are 11 events. These are data, and I can just click on finish. So what you see here in the whole process is that although there are some glitch on the user interface where we have to keep on doing the same thing a couple of times, but eventually a table was created, and this table was associated with a event stream, right? So inside this table, these are the data that you can. If I click on query table, you will see this is the KQL that we see just now. I run this. Oops, it's still running. To show, we have to wait a little bit until the event data eventually comes in. Then there's test event data. You can also do like count, right? For example, this is the KQL syntax. I have to name the table and do a count. How many rows do I have? 2,200. After a little bit, 2,400. So this is the um, event house and the event stream, where event stream is pouring data into the event house. So now let's look deeper into the other path of real-time analytics. What we just had was we have this event stream going to the event house, store the data coming from the sample source or any external source going into, or I should say, represented by this event stream. Event stream is the mechanism receiving the data and save it into Microsoft network, then save it into an event house. Then we use a KQL query. You shall see taxi takes 100 or taxi count for reporting, for querying, right? Now, what about this part where you do action? What you can do here is you can create. Now, let's create a new item where you have a get data of event stream, you get store data of an event house, and you can prepare data. We are not going to do that, but how about check data, where you have an activator? You click on activator, you create an activator where inside which you will create a reflex. A new activator, you will try to get data. How about we get data from our event stream, the event stream we just created? So I'm going to do a event stream. This is the event stream we created, right? But as you can see, there are other Microsoft sources that you can utilize. So, but let me choose this one. And now it's loading the data It's analyzing the schema basically. What it does right now is to see what is in this event stream so that it can react. Let's say we try to see something. If a chip distance is too far, we might have a warning. So let's get next. And we're connecting to this. We are not creating the warning yet. We are just connecting to this this table. Set activator as the destination. Okay, so you can also, of course, open event stream and do further processing here, but we don't need to do that. Now we have the stream. We can create. New rule. New rule. Each rule is something that's happening. That's on every value. You can only or choose the missing the data or something like right. So this will be on every value of equal to let's say greater than 10. Here is the event and monitor. We need to just wait a little bit. So let's wait a little bit until the data comes in. And now let's go to the alert. And here is it's still loading. This is where you can send email. You can have multiple things. You can do a Teams message or event, or you can trigger another item like Fabric Power BI, for example, Power BI dashboard, right, to Jimshan. And then with this subject, with this headline, alert message, some kind of alert message, right? And then you can on every value is greater than. Still loading the schema. We are going to wait for the chip distance, but the value is, let's say, I think it failed somehow. Am I getting this right? Stream event. Somehow it's still loading, so maybe I'll just wait a little bit before it comes back. Okay, so I wait for a while, and finally the data comes in. So now you can see there is a select column, right? If I choose a fair amount, I think what we talked about was the chip, was the distance of chip distance. And click on chip distance, and it's greater than. There should be chip distance is greater than 20. Then it will trigger an email. So I'm not going to try to save it because I don't want to send myself a bunch of emails in my St. Peter's account. But basically, this is what you will see. The other way around, that you can have this event stream to reflex, right? Here, directly trigger action, trigger email. It can be an email, it can be a Teams message, or it can be something within. Just slow. I think once it started, once this event, it can trigger an email, a team message, or any Fabric item. But as you can see, I'm running this on my laptop, and the resource is not limited. Before that, when I run all the data science jobs or there are other jobs, it looks okay, right? That gives you a hint on how costly this is. It's taking a lot of resources. So this is really like killing the performance. Although this is just for display, it's already killing me a lot of killing a lot of performance, right? So let me delete this. Try to save some money. Are you sure? Yes, I want to delete this. Or maybe I'll do this later. Let me cancel this. I'll do this later. But let's go to the last piece. The last piece of this puzzle is the real-time dashboard, right? We got the event stream generating receiving the data and pass that to either action, where you can send emails and Teams message, or going to the event house where you can store data. And you can use KQL to query against the event house. Now, how about just display, visualize those? Let's go to creating a new item. And here we get data, we store the data all the way till visualize data, right? And we'll click on real-time dashboard, and I'm going to create one. Let's call it test. Oh, I already have some nice names here. Test RT data, test RT dashboard. Recent deleted. Okay, this is a typical example you will see error you will see. If you so there is still some glitch between Fabric's user interface and its core, it's the backend. If you have some name recently used, you cannot use it for a while, right? Because I recently used that. At least right now it's making an error message, but you can see it's not as synced as we would like to see. But I didn't expect this error, but I'm happy that it shows up so that you know what's happening. Anyway, I'm going to call it 2. And so as you can see, this one, just like any other dashboard you have been utilizing, have different tiles where you can place your data set and display. So I'm going to add here, and I need to introduce a data source, and I'm going to use one lake from Fabric. If you want to import data from Azure, then it's Azure Data Explorer, but for now, it's one lake hub, and I'm going to choose the event house I just created. So you have this test event house, add, and I'm going to use the taxi table we created. And I can actually, this is the KQL, right? I can run this, get the data, and this apply change. Once the data is here, it's showing me a display. Then I think that serves a purpose. You can see how you will add new tiles. You can add a new data source, apply data source to the tile, and then you can modify the tile to use different visual type. For example, if I decide to choose, let me find one heat map. And this is how you would see, right? If I apply change, then this is how visualization will show up here. So this serves the purpose of completing this whole event stream to action or to storage and display visualization or getting query. So this completes the Fabric real-time hub.